Hello and welcome to our presentation on our demo paper and project factFUSE, Managing Versioned Web Resources in the File System. So as the volume and variety of data increases every year, efficient data management solutions become more and more important. And especially since the beginning of the corona pandemic, the need for distributed data management solutions has become very apparent. In this context, solutions like Dropbox or the several Drive services have become immensely popular, but they are not based on web standards, and also they lack important interoperability features if you think in the context of production. Additionally, most households, people in home office, and also most production environments still rely on traditional computer file-based data management in the file system. And there's a huge gap between these old approaches and newer resource-oriented architectures and semantic data management. So our approach is to provide a solution for distributed data management that is based on several web standards and connect those to the environment of the file system. Standards that we implement include the linked data platform specifications, RDF, the HTTP Memento protocol, PROF, and REST for HTTP operations. To combine these concepts of the file system and also the web and web resources, different components that both bring to the table have to be brought into line. So on the one hand, we have computer files, hierarchical directory structures, metadata, and file system operations. And on the other hand, global identifiers for resources, client-server paradigm, outgoing and ingoing links, and the HTTP operations that should be done RESTfully. So the main idea was to map a linked data platform to the file system. Linked data platforms are W3C recommended sets of specifications on how to access and interact with resources from servers that expose their resources as linked data. And linked data platforms introduce containers as structural components that can contain RDF resources, binary sources, as well as other containers. So this provides a very hierarchical structure to linked data servers that can be easily and very straightforward be mapped into the hierarchical file system. So once a container has been chosen as a root container, it gets mapped to the mount volumes mount point, and other containers are mapped to directories, and resources are mapped to files in their respective file format. So this allows for the joint management of RDF resources and arbitrary binary resources in the file system. Also, it makes the translations of the persistent URIs that we assign to web resources to the relative paths in the file system very easy. factFUSE automatically detects changes to resources in the file system representation and synchronizes them to the server side while automatically applying versioning mechanisms. So let's say we want to edit our RDF1 resource and delete our RDF2 resource in the file system. These file system calls are translated into according HTTP calls and applied to the linked data platform. Each change to a resource creates a new revision, which results in a linked version history of each resource. On the other hand, there are change notifications for changes that occur on the LDP side. If there's a new resource in the LDP, this is detected, notified to factFUSE, and applied to the file system representation. This functionality makes the drag and drop integration of new arbitrary data into existing LDP graphs very easy. Also, in addition to the containment and revision relationships, factFUSE has since been extended to automatically collect various other provenance metadata. To display and explore metadata, factFUSE extends the file system with user interfaces. So factFUSE provides transparent discovery of the version history of each resource and also other RDF metadata. In the version history, there's an overlook of all revisions. You can interact, download, and restore certain revisions and get an insight into the activities that generated a revision, as well as discover and explore various related files that influence the creation of a revision. So now let's take a look at how this looks in the implementation in a demonstration video. Welcome to factFUSE. With factFUSE, you can connect to a linked data platform and mount its resources to your local file system. Inside the mounted volume, all the web resources are accessible as files that you can view, edit, move, rename, and delete. factFUSE automatically detects and synchronizes your local changes with the server. You can interact with the resources in your favorite desktop apps and modify them. factFUSE automatically tracks your file's version history as well as additional provenance information that you can access from within the file system. Integrating new resources into existing graphs is as easy as dragging and dropping them. So this is factFUSE. factFUSE, in summary, features a custom user space file system to interact with linked data platforms, an extensible commit system to customize metadata and provenance information that is collected. It provides user interfaces in the file system for the display and exploration of metadata, and it is all bundled in a desktop application called factFUSE. factFUSE allows the joint management of computer files, semantic data and metadata, and is based upon web standards such as the Linked Data Platform Prof and the HTTP Memento protocol. It offers distributed data management and version control in the file system and is available as open source. Also, if you're interested in more information how this all works, please check out our work on the unified data management framework that we call factStack. So thank you very much for listening and for your attention, and goodbye.